Okay. A rhombus has sides of length 60 units each. You see, it says each. So this side AB is 60 units, AD is 60, DC is 60, and BC is 60, right? And the lengths of its perpendicular diagonals are in the ratio 2:1. We do not know what the lengths of the diagonal are, but that's what the ratios are. What is the area of the rhombus in square units, right? I know that the formula for the area of the rhombus is equal to the product of its diagonals, right? Let's say if I take the first diagonal as x and the other diagonals as 2x, right? I can do that because in that case I am representing the ratio, right? And area, for the area I have to divide it by 2 because I have to take out the average of the product of the two diagonals, right? So if I do that, right, 2 and 2 cancel out and I get area is equal to x squared, right? Okay, the next thing that I have to do is, if one side is 2x, the other is x, right? So if I have to consider one right angled triangle, can I say that the one that was actually 2x for this right angled triangle is x, and the one that was initially x, from B to D, let's say take that diagonal as x, so from B till this point that is supposed to be half of x, right? So if I consider this right angled triangle and apply the Pythagorean theorem, I can say that 60, which is the hypotenuse, is equal to x squared plus 1 over 2 x and then whole squared, right? Okay, x squared plus 1 over 4 x squared is equal to 60 squared, right, which is equal to 5 over 4 x squared. If I arrange this equation for x squared, I'll get x squared is equal to 60 squared times 4 over 5, and if I'll solve this thing, I'll get the answer 2880, right? Now I'm saying that this x squared is 2880, which is supposed to be the area, because initially we decided that whatever area would be, that would be x squared, right? And now that I have solved for x squared, so 2880 is supposed to be the area of the rhombus in square units.